guys, welcome back to BiharGeeks. So today we will solve a sliding window maximum problem using an optimized approach that we call it that sliding window approach. Okay. So if you're preparing for the FANG interviews, this is a must-known problem. Okay. So the problem statement here says that we have given an array. Okay, that we call as a nums, and we have given a one more integer, that is k must be a window size. Okay, so we have to find the maximum element within a window. Okay, like if you see that this example, like as the window size is 3, so we will pick up 3 elements from here, and as you see 3 is the maximum one, so we will return 3 as a max. Okay, then our array move to the next, so there will be 3 elements again, so you see that 3 is the maximum. Okay, next move, our window move to other forward direction, so now you see that the 5 is the maximum. So we will move in the forward direction as we reach to the last, so we will get all the based on the window we will get a maximum element, so we just need to return that. Okay, maximum. Fine. So as I already told you that we will use an approach that is called the sliding window. Okay, we will use a DQ here. So we will use the DQ. Basically, DQ is a doubly ended queue. Okay, so we will keep the track of the indexes in a decreasing order. This is allow us to use a efficient way to find the maximum element in a optimize, or we can say that the with the complexity of O of n. Otherwise, if we are using the brute force, in that case we have to iterate for the every sub array. Okay, so in that case our complexity will be n multiplied by the k, whatever the window size. So also the process used to be like a little slow in that case, so that's why we are using the sliding window and using that dq here. Okay, so let's move to the logic here. First, we have to put the edge case here. Okay, maybe our array is null. Okay, or maybe the queue, or you can say that the window size is maybe equal to 0 or negative also. So we have to handle those uh, edge cases. Okay, so we will check that. Sorry, fine. And now we will put it in OR condition that k should be not be negative or equal to 0. It should be something. Okay, otherwise we will just simply return the empty array. Right, fine. This is the edge case done. Now we will take out the length of the array. Okay, length ng h. Fine. Now we need a result which we will return at the end. Sorry. Result equal to new int where k will be the our window size. Okay, and we have to plus 1, and we have to subtract with n. Okay, whatever the key size, this way. Fine, so we will store the result here. Okay, now we need to define a dq here. Fine, dq which will be of type integer only. Fine, degr. Okay, and we'll name it as same dq. Deque. Fine, that will equal to new linked list. Fine, this is done. This will store the indexes. Okay, this is for the result, and dq is basically for storing the indexes. Fine, now we have to iterate. Okay, so we need for n. Sorry. Now what we have to do, we have to remove the element out of the window. Okay, fine. So what we have to do, we have to put if DQ is not empty. Okay, DQ is not empty, and DQ dot peak first. First will be less than I minus k plus 1. Okay, when this condition gets true, like we have to remove the out of the window whatever the extra element we have. Okay, so in that case we just simply do dq dot poll first. Fine, this is done. Now if is done, now inside this if, now what we have to do, we have to remove the smaller elements in the window from the back. Okay, so for that we need a loop here where not equal to d eq same we have to check is empty or not. E is empty, and I have to put the condition nums. Okay, inside that we will pass dq dot peak first. Sorry, first. Okay, and we have to check it with, is it less than equal to whatever the value currently we are, right? If the condition gets true, so in that case dq dot poll last will take it. Fine, we have removed that the smallest element. Now we have to add the last index. Deque dot offer last, offer last. Okay, inside that we have to put the index of that. Okay, as you know that dq is only we are using for storing the indexes. Okay, now we have to store the max whatever the max value we get in that window. Okay, so for that we will put if I is greater than or equal to the k minus 1 whatever the window size we have. Inside that what we have to do, result, and inside that I minus k plus 1. Okay, and that will be equal to nums, and inside that dq peak first we have to just copy it from here. Dq first, where we have to copy inside this array. Okay, this is done. Now after that everything is done, we get a max value and we have put it inside a result. Okay, so this loop is ended over here. Now we just need to return the result here. So return result result. Okay, let me run this. Okay, it's got accepted. Let me submit this. Wrong answer. Fine, what we did wrong, let me just check it. First we have take we have a edge case, we have done that. Then num dot length int result, whatever the case size is there, we have put it. Then we have taken the dq to store the indexes. Then we have moved the loop from I to till the length of the array. Then we have to remove the element out of the window. So we have put it if is empty and dq peak first I minus k plus 1. Okay, like we have done. And after that DQ poll first we have did, and after that we have a while loop. Inside the DQ is empty nums. Okay, okay, okay. We have to check it from the last instead of first. Last greater than or equal to poll, because we are doing poll last only, na? Okay, DQ of a last, and then we are doing. Okay, let me run again. Fine. Let me submit this again. Okay, fine. Okay, let me explain this code. Okay, so why we have used the DQ? We have maintained the element in the decreasing order so that the front always hold the maximum. Okay, and we secondly we have did that removing the element from the out of window. We remove the first element if it's outside the current window, because as you see example, whenever we iterate we just remove the first element, okay, and then we are picking the next element from here. Okay, then we what we had did, we have removed the smaller element. If a new number is larger than the existing one, we just DQ and remove it. Okay, so the time complexity, if we talk about, so each element is added and removed at most once from the DQ. Okay, so the time complexity is O of n. Okay, in that case. Otherwise, if we use the brute force, on that case, our complexity will be nearly n multiplied by the k, that is window size. Okay, so the conclusion come out that we have solved this problem using the sliding window, and it's a common question basically asked in Google, Amazon, and Microsoft. Okay, so comment below if you have any question, and don't forget to like, share, and subscribe to Bihar Geeks. Okay, thank you for watching. Bye bye.